A typical resistance spot welder like this can range in price from around $200 to over $800. That's a little out of my price range, so for this project, let's make this one from common materials and for just a few bucks. This modified transformer is the heart of the spot welder, and you might remember it as the metal melter. If this doesn't look familiar, check out how this was made and what it can do in some of my other videos. I found a practical application for it in making a spot welder like this one. To get started, I'm going to measure the base of the transformer, and it looks like it's about 4¼ inches wide. I found a 6-foot piece of 1x6 common board that will be perfect for this. Using my chop saw, I'll cut 2 pieces of the board so that they're both 12 inches long. Then another piece gets cut at 42 inches. I'm trimming this piece down with my table saw so that it's about 1/4 inch wider than the transformer base, and in this case that measures out at 4½ inches. Then it gets chopped into 3 different lengths measuring 24 inches, 12 inches, and 4 inches. Next I found a 2x2 and I'm cutting the nicest parts of the beam into 2 pieces measuring 13½ inches long. 2 other pieces are cut at 4 inches and everything can be placed together to see how it fits. That's the rough idea right there, and I'd like to knock down the sharp edges, so I found a 3/4 inch rounding bit and routed the appropriate edges to give it a smoother feel. These front pieces are going to be my electrode holders. The edge of this scrap piece of wood works as a template to draw a 90-degree angle into the top piece about 1 inch from the end. I don't have a bandsaw, so I'm improvising with my bench vise and a jigsaw to cut this piece out, and it worked. You'll see what this groove is for in a bit. The next part is to cut out the pattern I drew on the back panel. So I'm going to utilize my vise once again and use an 1132 drill bit to cut holes in all the corners so I can get back in there with my jigsaw. These holes will be for a switch and a power cord, and all this panel needs now are 2 pilot holes drilled in the appropriate places for the switch. I'm thinking I should give this a paint job, so all the panels get sanded with an orbital sander, then laid out for priming and painting. For colors, I'm thinking black and yellow. With the paint drying, I've gathered up a few components that were saved from the same microwave I got the transformer from. To see all the amazing things that I got from that project, make sure you check out my video on salvaging a microwave I found in my neighbor's trash can. I'm going to use the power cord, these wired spade connectors, the door handle, and this contact switch. Aside from the wood, the only parts I needed to buy were a single pole light switch with matching cover, copper offset terminal lugs, a couple of 1/4 inch thick screws, 2 small nails, and a length of 6-gauge solid copper wire. The copper wire gets marked off in 1-inch increments, and 2 pieces are cut off using the wire cutter on my pliers. These are going to work as my welding tips. The copper lugs have an adjustable screw that can be loosened to insert the solid copper wire. When it's tightened back up, it looks like this. Alright, the paint on the wood panels is dry, and I've added the switch to the back panel to make sure it fits, so the next step is to flip it over and press the power cord down into the hole at the bottom. The thick piece at the end of the cord prevents it from pulling back through the hole. I'm ready to piece this back together, so I'm drilling a couple of pilot holes into the bottom and securing the back panel with a couple of screws. Now the front 2x2 supports are added and the metal melter is placed on the base about 1 inch back from the supports. I'll add a screw to one of the corners to help keep it in place, and at this point I'm ready to rig up the electrical system. Taking the green wire from the power cord, I'm stripping open a gap in the plastic to expose the bare cord. This will wrap around the grounding screw on the power switch. The end of the wire has a hole I can use to insert another short screw and work that down into the opposite corner of the transformer base. Not only does this secure the metal melter in place, it also grounds out the transformer core at the same time. Okay, I've exposed the copper on the black wire, and that'll get connected to the bottom terminal of the power switch and screwed down tight. This salvaged spade connector still fits onto one of the transformer's primary terminals, so with that on, the other end of the wire can be connected to the top terminal of the power switch. Now the switch can be screwed down permanently, and a cover plate added to protect from electric shock and to make it look nice. The other spade connector that was salvaged goes on the left terminal of the primary coil. And we could finish the electrical here, but I want to add one more switch for convenience. This switch still has the original wires and connectors from the microwave, and I've just added a wrap of electrical tape to make sure I don't get shocked while touching it. I'll strip the end of the white wire and twist it together with the other white wire coming off the primary, then use a wire nut to cover the connection. Now the black wire is joined with the white wire coming from the power cable, and the electrical system is complete. I added this microwave door handle to the top panel, and I'm screwing it on to see how it holds up. The alignment looks good, and when I pick it up, it seems to support the weight without any problem. Alright, with the cables laying out the front, it's time to close up the side panels, and I'm doing that by drilling holes and adding 6 screws on each panel to make sure it's held securely. The next step is to construct these electrode holders. I chose to use a 3/16 bit to drill a hole into both tips of the 2x2s, which you can see got painted yellow. The hole is big enough to prevent the wood from splitting when these screws go in, yet small enough to hold them in secure. This is the top piece, and I'm going to add a switch to the side, about 1/2 inch from the tip. It gets set at a slight angle, and the 2 small nails are hammered down into the holes already in the switch. Now the 2 beams can be slid into the front of the casing, with one under the wire and the other over top. To secure them in place, I'm using some scrap wood to keep them an equal distance apart as I drill a hole through the side of the casing and into the beam. I've pushed a nail into the hole, and now you can see this top piece is able to pivot freely. It should be obvious now why we needed that notch near the base. The bottom beam also gets a hole drilled on either side, as well as its own set of nails to keep it from sliding around. The welding tips can be attached now, so we push one of the hex screws through the hole in the lug and then join it to the right side cable. That gets tightened securely into our pilot hole, and all that gets repeated on the top. The misalignments can be fixed by bending the lug slightly inward, and now we've got perfect contact. To finish this off, I'd like a way for the top beam to stay suspended on its own, so to address the challenge, I'll add a couple of screws and a thick rubber band. The system is finished, my very own spot welder, and for less than $10 in materials. Let's see if it works. Power cord plugs in, and with the electrode tips touching, I'll press the button to engage, but nothing's happening. Well, that's because the safety switch is still off. Let's try it again. This time when I press the button, the system hums, and when the tips touch, I see the high amp sparks I was hoping for. I don't have any sheet metal handy, so I decided to try using these washers for my first experiment. The pressure holds them in place hands-free, and with the system energized, it only takes about 3 seconds to fuse them together. I'm trying it again with a third washer, being careful not to touch these because they're extremely hot. Surprisingly, it even worked on thicker welds like melting a washer to this steel spike. Trying to break them apart by hand was a fruitless effort, so I tried using pliers, and even that was a bit of a challenge, but I got it. That just goes to show the welds are pretty strong. A feature I really like about this design is that the electrode holders can be removed, allowing the user to extend the welder's reach and access difficult angles. They go back in as easily as they came out, and all it takes to secure them back in place is a little wiggle and the replacement of the locking nails. The elastic band is easy to replace, and it's doing a great job providing back tension after I make a connection. I tried welding a couple of iron nails in an X pattern, and since the heat was concentrated in the center, it didn't burn my fingers. The power of the metal melter is still evident in the way the iron is boiling on this nail, and if allowed to continue, the nail melts down into a little ball of liquid metal. When it's time to replace the electrode tips, just loosen the tensioner, remove the spent electrode, and replace with a fresh piece of your copper wire. If you do it this way, you can get about 12 tips for $1 because the wire is not that expensive. Well, now you know how to make my version of a spot welder from easily accessible and low-cost parts. If you like this project, perhaps you'll like some of my others. Check them out at thekingofrandom.com.